There, our conventional perspectives of space and time strangely change.
Your nose is just a little closer to me than your ears. Light reflected off your nose reaches me just an instant in time before your ears. But suppose I had a magic camera so that I could see your nose and your ears at precisely the same instant.
With such a camera, you could take some pretty interesting pictures. Paolo says goodbye to his little brother Vincenzo.
Ciao, Vincenzo.
Ciao, Mom.
And rides off. He's now going more than half the speed of light. He's almost catching up with his own light waves. This compresses the light waves in front of him, and his image becomes blue. The shorter wavelength is what makes blue light waves blue. Also, Paolo becomes skinny in the direction of motion. This isn't just some optical illusion. It really happens when you travel near the speed of light. As he roars away, he leaves his own light waves stretched out behind him. Long light waves are red. We say that his receding image is red-shifted. Now, Paolo leaves for a short tour of the countryside. He experiences something even stranger. Everything he can see is squeezed into a moving window just ahead of him. Blue shifted at the center, red shifted at the edges. To a passerby, Paolo appears blue shifted when approaching, red shifted when receding. But to him, the entire world is both coming and going at nearly the speed of light. Roadside houses and trees that he's already gone past still appear to him at the edge of his forward field of view, but distorted and red shifted. When he slows down, everything again looks normal. Only very close to the speed of light does the visible world get squeezed into a kind of tunnel. You would really see these distortions if you could travel near the speed of light. Someday, perhaps, interstellar navigators will take their bearings on stars behind them, whose images have all crowded together on the forward view screen. The most bizarre aspect of traveling near the speed of light is that time slows down. All clocks, mechanical and biological, tick more slowly near the speed of light. But stationary clocks tick at their usual rate. If we travel close to light speed, we age more slowly than those we left behind. Paolo's watch and his internal sense of time show that he's been gone from his friends for only a few minutes. But from their point of view, he has been away for many decades. His friends have grown up, moved on, and died. And his younger brother has been patiently waiting for him all this time. The two brothers experience the paradox of time dilation. They've encountered Einstein's special relativity.
Vincenzo.
This was just a thought experiment, but atomic particles traveling near the speed of light do decay more slowly than stationary particles. As strange and counterintuitive as it seems, time dilation is a law of nature.
Traveling close to the speed of light is a kind of elixir of life. Because time slows down close to the speed of light, special relativity provides us with a means of going to the stars. This region of northern Italy is not only the cauldron of some of the thinking of the young Albert Einstein, it is also the home of another great genius who lived 400 years earlier, Leonardo da Vinci. Leonardo delighted in climbing these hills and viewing the ground from a great height as if he were soaring like a bird. He drew the first aerial views of landscapes, villages, fortifications. I've been talking about Einstein in and around this town of Vinci in which Leonardo grew up. Einstein greatly respected Leonardo, and their spirits, in some sense, inhabit this countryside still. Among Leonardo's many accomplishments in painting, sculpture, architecture, natural history, anatomy, geology, civil and military engineering, he had a great passion. He wished to construct a machine which would fly. He made sketches of such machines, built miniature models, constructed great full-scale prototypes. And not a one of them ever worked. Mainly because there were no machines of adequate capacity available in his time. The technology was just not ready. The designs, however, were brilliant. For example, this bird-like machine here in the Leonardo Museum in the town of Vinci. Leonardo's great designs encouraged engineers in later epochs, although Leonardo himself was very depressed at these failures. But it's not his fault. He was trapped in the 15th century. A somewhat similar case occurred in 1939, when a group of engineers calling themselves the British Interplanetary Society decided to design a ship which would carry people to the moon. Now, it was by no means the same design as the Apollo ship, which actually took people to the moon some years later. But that design suggested that a mission to the moon might one day be a practical engineering possibility. Today, we have preliminary designs of ships which will take people to the stars. They are constructed in Earth orbit, and from there, they venture on their great interstellar journeys. One of them is called Project Orion. It utilizes nuclear weapons, hydrogen bombs, against an inertial plate, each explosion providing a kind of putt-putt, a vast nuclear motorboat in space. Orion seems entirely practical and was under serious development in the United States until the signing of the international treaty forbidding nuclear weapons explosions in space. Personally, the Orion starship is the best use of nuclear weapons I can think of, provided the ships don't depart from very near the Earth. Project Daedalus is a recent design of the British Interplanetary Society. It assumes the existence of a nuclear fusion reactor, something much safer as well as more efficient than the existing nuclear fission power plants. We do not yet have fusion reactors. One day, quite soon, we may. Orion and Daedalus might go 10% the speed of light. So a trip to Alpha Centauri, 4.5 light years away, would take 45 years, less than a human lifetime. Such ships could not travel close enough to the speed of light for the time-slowing effects of special relativity to become important. It does not seem likely that such ships would be built before the middle of the 21st century, although we could build an Orion starship now. For voyages beyond the nearest stars, something must be added. Perhaps they could be used as multi-generation ships, so those arriving would be the remote descendants of those who had originally set out centuries before. Or perhaps some safe means of human hibernation might be found, so that the space travelers might be frozen and then thawed out when they
arrive at the destination centuries later. But fast interstellar spaceflight, approaching the speed of light, is much more difficult. That's an objective not for 100 years, but for 1,000 or for 10,000. But it also is possible.